The Jordan Show on YouTube.
Hey everyone, welcome back for another deep dive. Today we're going to be exploring the world of debugging.
Sounds fun.
But we're not just talking about fixing code here.
Right.
We're going kind of deeper, like almost philosophical.
Oh, interesting.
Yeah. We'll be looking at how debugging is really about this fascinating intersection between like human thinking and complex systems.
I like that.
Yeah. And we've got some really cool sources we're going to be using as our jumping off point.
Okay.
So we've got some stuff about ENS, the Rule of Halves,
Nice.
and then even like the philosophy behind troubleshooting.
Cool. I'm excited to dig in.
Yeah, me too.
It's amazing how debugging can be like almost like a mirror. You know?
Yeah.
It reflects back our own understanding or sometimes even our misunderstandings
Right.
of the systems we build.
Yeah, it's like a constant reminder that like we're the ones who made these systems in the first place. So we're the ones who are responsible for understanding them. Their quirks, their complexities, all of that.
All of it.
Speaking of complex systems, let's jump back in time for a second.
Okay.
Let's go to 1945
All right.
and talk about ENIAC,
ENIAC.
one of the earliest electronic computers.
Wow. So imagine like a computer that takes up this entire room.
Oh, wow.
With miles of wiring, thousands of vacuum tubes.
Oh, my God.
The programmers, many of whom were women,
That's right.
they had to physically manipulate these switches and plugs
Wow.
to program it.
Yeah.
So debugging involved like meticulously tracing wires,
Oh, boy.
checking those tubes one by one.
It's a whole different world.
Oh, it was a Herculean task.
It's mind-boggling to think about the patience
I know.
and meticulousness those early programmers must have possessed.
Totally.
But here's what I find even more interesting.
What's that?
Often, the errors weren't in the machine itself. They were in the assumptions made during programming.
That's a really good point. I think that's why ENIAC is such a compelling case study.
Right.
Because it underscores that even with like the most cutting edge technology, our human understanding and assumptions
Yeah.
play such a critical role.
Such a critical role.
Yeah, think about how often we encounter problems in our own lives
Oh, yeah.
because of misinterpretations.
Yeah, for sure.
Or unexamined assumptions.
Well,
It's like
yeah.
debugging isn't just about fixing machines, but also debugging our thought processes.
That's a really insightful point.
Yeah.
It's so easy to think you understand something completely
I know.
and then later on realize your assumptions were off.
Totally.
So, like, how do we avoid falling into those traps? Are there, like, techniques that can help us debug our thinking?
Absolutely. There are. One classic approach is the rule of halves.
Good.
It's a systematic way of finding the root cause of a problem.
Okay.
So essentially, you just break down that potential problem space
Okay.
into halves
Uh-huh.
and test at the midpoint
Gotcha.
and focus on whichever half the issue persists. And then you just keep repeating that process
Okay.
until you pinpoint the source of the error.
So it's like a divide and conquer strategy
Exactly.
for troubleshooting.
Yes.
Okay. I can see how that would be helpful in narrowing down the possibilities,
Right.
especially when you're dealing with a really complex system.
Yeah, exactly. Imagine you're, let's say, debugging some code.
Okay.
That's generating the wrong results.
Okay.
You could use the rule of halves, like comment out half the code,
Okay.
run it again,
Right.
see if the error's still there.
Gotcha.
If it is, you know the problem's in the half that you kept active.
Okay.
If it's not, it's in the half you commented out.
I see.
And you just keep doing that
Okay.
until you get to that faulty section.
That's a really great example. It shows how this technique can be applied, not just to physical systems like ENIAC, but also to like abstract ones, like software.
Exactly.
I am curious though, what about those situations where the problem isn't so easily divided in half? What about cases where the issue's more, I don't know, nuanced or interconnected?
Yeah, that's a really good question. And that kind of gets to one of the limitations of the rule of halves.
Okay.
So it works best when you have a linear problem space.
Okay.
Where you can clearly isolate and test different segments. But things are rarely that straightforward
Yeah.
in real world scenarios.
Definitely not.
Think about like troubleshooting a recipe that went wrong.
Okay.
You might have like ingredient ratios, oven temperature,
Yeah.
even the humidity in your kitchen.
Yeah, lots of factors.
Yeah.
That makes a lot of sense. So it seems like the rule of halves is a good starting point. but it needs to be like combined with other techniques
Yeah.
and maybe a good dose of intuition.
Yeah, exactly.
So is that where this idea of spiritual debugging comes in?
You got it. It's not about like supernatural forces or anything.
Yeah.
It's about recognizing that effective troubleshooting often involves qualities that go beyond just pure logic.
I see.
It's about like embracing uncertainty,
Okay.
cultivating patience,
Uh-huh.
and trusting your gut.
Okay.
You know, these are all aspects that can help us navigate the complexities of debugging,
Yeah.
especially when that answer isn't immediately obvious.
This is where it gets really interesting for me.
Yeah.
I'm starting to see how debugging is about so much more than just fixing bugs. It's like a journey of exploration, like a process of uncovering these hidden complexities.
Yeah.
And ultimately, it's a reflection of our own understanding of the world.
That's beautifully put. You know, in a lot of ways, that journey,
Yeah.
it mirrors the broader human experience of learning and problem solving. It's about being open to new perspectives, embracing uncertainty, and trusting our intuition alongside logical reasoning.
I love it. Okay, so we've talked about the historical context with ENAS, the systematic approach of the Rule of Halves.
Yep.
And now this like intriguing idea of spiritual debugging.
Right.
So I'm eager to dive deeper into like some practical techniques
Okay.
and tools that can help us become better troubleshooters,
Yeah.
both in the tech world and beyond.
Let's do it. There's a whole arsenal of techniques out there waiting to be explored.
Awesome.
Yeah, each with its own unique way to approach and unravel those complex problems.
Let's get to it.
Okay.
So you've got this whole spiritual debugging thing, embracing uncertainty, patience, intuition.
Yeah.
But how does that actually like play out when you're facing a real problem?
Okay, so think about it this way.
Okay.
Have you ever had to deal with like a really stubborn bug?
Oh, yeah.
One that just like defies logic?
Oh, totally.
That's when humility becomes really crucial. You know, recognizing that maybe you don't have all the answers,
Yeah.
that there might be something you're just not seeing.
Right.
That's often like the first step to a breakthrough.
Yeah, I can definitely relate to that. It's so easy to get fixated on one way of thinking, especially when you've been staring at the same code for hours.
Yeah.
Sometimes you just got to step back.
Yeah.
Admit you need a fresh perspective.
Totally. And that's where patience comes in.
Right.
Debugging is rarely like, a quick fix.
Oh, no, definitely not.
It often requires, you know, being willing to experiment,
Yeah.
to try different things,
Yeah.
and to accept that you might hit some dead ends along the way.
Yeah, it's like navigating a maze.
Right.
Sometimes you have to backtrack. Try a different path to find your way out.
I love that analogy. And along those lines, you know, think about intuition.
Okay.
Have you ever had like that aha moment?
Oh, yeah.
Like a sudden flash of insight
Uh-huh.
that just leads you to the solution? Oh, absolutely.
It can almost feel like a sixth sense.
Yeah.
Like a hunch
Uh-huh.
that guides you in the right direction.
Sometimes it's not even a conscious thought.
Right.
It's just this feeling that something's not right,
Totally.
or like a sudden urge to try something specific.
I think those intuitive leaps, they often come from like a deep understanding of the system
Yeah.
that you're working with. It's
Yeah.
like your brain is like processing stuff in the background, making connections that you're not even aware of.
Right.
And then suddenly the answer pops into your head.
It is amazing how our minds work like that.
I know, right?
So if we combine this like intuition thing with the logical approaches like the Rule of Halves,
Yeah.
it seems like we're building a more like holistic way of troubleshooting.
Exactly. It's about recognizing that effective debugging uses both sides of our brains, the analytical
Yeah.
and the intuitive. We need logic to break things down.
Right. Test hypotheses.
Yeah.
But we also need intuition to guide us when things are uncertain
Okay.
and to make those creative leaps that lead to breakthroughs.
I'm really digging this approach. It's like way more well-rounded
Yeah.
than just sticking to like rigid procedures.
Totally.
But, let's talk about some more practical techniques.
Okay.
Earlier, you mentioned some other methods besides the Rule of Halves.
Right.
Can you walk us through a couple of those?
Sure. So one that can be really helpful is binary elimination.
Okay.
It's similar to the Rule of Halves, but instead of like physically dividing a system,
Right.
you're systematically ruling out potential causes one by one.
So, like, going through a checklist of possibility,
Exactly.
eliminating them till you find the culprit.
Yeah, so imagine you're trying to figure out why your car won't start.
Okay.
You might check the battery,
Uh-huh.
the starter, the fuel pump,
Right.
and just, eliminate each one as you go. It's helpful when you have a limited number of things to check.
That's a really clear explanation. It seems like, binary elimination could be good for everyday problems too.
Yeah, totally.
Like figuring out why your internet's not working.
Yeah.
Or why your washing machine is making a weird noise.
Exactly. It's a really versatile approach.
Okay.
And speaking of versatility, let's talk about fault injection.
Fault injection.
Yeah.
Okay, I'm intrigued.
So this one might sound a bit counterintuitive,
Okay.
but basically it involves intentionally introducing errors or changes into a system
Okay.
to see how it reacts.
Oh, interesting.
It's a way to stress test components and find weak points.
So you're trying to break things on purpose.
Yeah, basically.
To see what happens.
Yeah, to see what breaks.
I could see how that would be useful. But it also sounds kind of risky.
It definitely requires caution
Yeah.
and expertise.
Right.
But it can be super effective. So, for example, software developers might use it
Right.
to simulate network outages
Uh-huh.
or hardware failures
Right.
to make sure their applications can handle it.
That makes sense. So it's like you're creating problems in a safe environment.
Exactly.
So you can learn how to deal with them in the real world.
Yeah, you got it.
Okay, I like that. So it's like shifting from a reactive to a proactive mindset
Exactly.
when it comes to troubleshooting.
It's all about building those robust and resilient systems.
Cool. Okay, so we've got binary elimination for systematically ruling things out, and fault injection for, injecting faults.
Right.
Seeing what breaks.
Yeah.
What other techniques are in our debugging toolkit?
Well, there's one that's surprisingly simple,
Okay.
but people often forget about it. It's called the swap and test method.
Swap and test.
Yeah.
That sounds pretty self-explanatory.
It is.
Okay.
So basically, if you think a certain component is causing the problem, you just swap it out with a good one.
Okay.
And see if that fixes it.
So if I thought my laptop's hard drive was failing,
Yeah.
I could swap it with a spare one to test it?
Exactly. It's a quick way to isolate whether a specific piece of hardware is the issue.
Yeah, that's true. Of course, this only works if you have spare parts,
Right. Exactly.
which isn't always the case.
Yeah, you're right.
But it's definitely a good one to remember.
Uh-huh.
Okay, so we've got a good mix of systematic approaches and more experimental techniques.
Right.
Any other debugging methods we should know?
There's one that's a bit unconventional,
Okay.
but it can be really effective. It's known as the rubber duck method.
Rubber duck method.
Yeah.
Okay, now that one definitely has my attention.
So the rubber duck method is based on this idea
Okay.
that explaining your problem to someone
Uh-huh.
or even just an inanimate object
Okay.
can help you figure things out. Clarify your thinking.
Oh, I've totally done that before. Sometimes just talking it out helps,
Right.
even if I'm just talking to my cat.
It's surprisingly effective.
Yeah.
By explaining it step by step. It forces you to organize your thoughts.
Right.
And you often discover things you missed.
So the rubber duck is like a sounding board,
Exactly.
helping you debug your own thought process.
You got it. And this highlights something we've been talking about.
Yeah.
Debugging is as much about understanding ourselves
Right.
as it is about understanding the systems we work with.
This is fascinating. We've gone from the rule of halves to talking to a rubber duck.
I know, right?
It really shows the different sides of debugging. It's a field that needs both, technical expertise
Yeah.
and a deep understanding of human psychology.
Absolutely. And as we get further into this spiritual side of troubleshooting,
Yeah.
we'll see even more connections between how we approach problems in tech and how we handle challenges in our everyday lives.
Wow. I'm really starting to see debugging differently now. We've talked about so much, from those actual bugs in ENIAC to the metaphorical ones and how we think.
And we've only just scratched the surface.
I know, right?
There's so much more out there, from the really technical stuff to the philosophical side of things.
It's like we've opened up this whole secret toolkit. And it's not just for computers.
Right.
It's for approaching any kind of tricky problem. But before we wrap up,
Okay.
what's the main thing you hope people take away from this deep dive? What's the core message?
I think the biggest takeaway is that debugging is all about discovery. It's about being curious, willing to experiment, and learning from everything we do,
Okay.
whether it works or not.
Yeah.
It's a mindset that can help us with any challenge in life, not just tech stuff.
That's a powerful message. It's not about always being right or having the answers.
Right.
But just being willing to dive in and learn.
Yeah, exactly. And debugging is a skill, you can get better at it. Just like anything else, it takes practice and patience.
Right.
And being okay with getting out of your comfort zone.
So it doesn't matter if you're like a coding expert or someone who just wants to be better at, I don't know, fixing everyday problems.
Yeah,
These ideas can be super valuable.
absolutely.
It's about that mindset of curiosity, persistence, and embracing the unexpected.
And most importantly, remember, we're all human.
Yeah.
We all mess up sometimes. The key is to learn from it.
Okay.
Yeah.
Yeah.
Use it as a chance to grow and never stop exploring.
I love that perspective. Turn those frustrating moments into chances to learn.
Exactly.
Well, as we come to the end of our deep dive here, I want to leave everyone with a little challenge.
Okay.
Think about a complex system that you deal with regularly. Could be your work, your social circle, even your own body.
Oh, interesting.
And ask yourself, how can the things we've talked about today,
Yeah.
like the rule of halves, binary elimination, the idea of interconnectedness,
Right.
even the rubber duck method,
Yeah.
help you understand that system better?
That's a great challenge.
Yeah.
And there's no one right answer.
Right.
That's the cool thing about debugging.
Yeah.
It's a personal journey.
Absolutely.
Always exploring, always discovering.
So go out there, embrace the bugs, and keep on debugging.
Have fun with it.
And if you've got any amazing debugging stories or aha moments, we'd love to hear them.
Yeah. Share them with us.